Alright, so for the first part of the question is to calculate the gradient of the curve of this equation. Okay, so therefore after simplify it, this is the equation. So with this type of equation, right, we want to find the gradient. So what should we do? Because we need to find the differentiation of it. Just a gradient. Okay, by finding the differentiation of y, we will find a gradient. So for this type of equation, we need to use product rule. How do we use product rule? Let's treat this part. How do we identify the equation where we need to use product rule? Means this equation need to use this the first part I call u times the other part which I call v. This type of situation we need to use product rule. So how do we use product rule? So the differentiated differentiation of y will be equals to differentiation of u with respect to x times v plus differentiation of v with respect to x times u. Alright, I know it sounds confusing, but it's really easy. Okay, so let's differentiate our u first. U is only x, so equal to 1. Alright, that's done for u. So we already have du over dx, and we already have u, which is x. Okay, and we have v. But v this time we need to use chain rule. Alright, what is chain rule? Which is treating this inside the equation inside the bracket. This time we treat as k equal x plus 3 and b equals to bracket k bracket to the power half. So we use dv, which is here, differentiation of v with respect to k times differentiation of k with respect to x over here. As you can see that after we minus cancel away this and this, we have dv over dx, which what we want. Alright, so after differentiating k, we have 1. After differentiating v, we have half k to the power negative half. And so our dv over dx is equal to 1 times half k to the power half, and which is, this is the answer. Realizing we're having a k there, taking the original value of k, putting it back, and this is our differentiated value of dv. This is our dv over dx. Okay, so once we have our dv over dx, we already have this, and we already have our b at here. So by using this, we can see that here's v. This is dy over dx. So we already have all this value, all the ingredients that we have here. Just sub it in accordingly, and then do the normal equation. As you can see, here will be our v. Where's our v? Our v will be here. And what's our du over dx, which is here. And here's our x, which is our u. And here's our dv over dx, which is got it from here. Okay, so after that, for the first part of our question will be finding a gradient at x equal to 1. So after combining everything together, we just need to sub our x equal to 1, and this 2.25 is our gradient. Okay, so later on, find the coordinates at point where gradient equal to 0. So gradient equal to 0, play around with the equation again, and then here is a part which is slightly confusing. Why do I say so? Because we call it a bit of rule of indices. Okay, so this part, as we see, is the same. That's why from here we bring this to left hand side, and then we bring over the bracket x plus 3 back to this side. So based on indices rule, these two same variables, we can use this rule, which is whenever there is divide of the same same value, same variables, we can minus. So it's half minus bracket minus half. Through here we have half plus half, which is become 1. So therefore this becomes negative x over 2 equal x plus 3. Okay, so that will be over the 2, and then next we will have x equal to negative 2. So if x equal to negative 2, sub our x back to the original equation, which is this one, and we will have negative 2. So our final equation, final coordinates of the point where gradient equal to 0 is negative 2 to negative 2. That's all.